Today we're going to take a look at how do we make something called a stem and leaf plot. A stem and leaf plot is a system used to condense a set of data with a stem and a leaf. The sets of data that we're going to take a look at today are pretty small. When scientists and statisticians use stem and leaf plots in the real world, they're using a stem and leaf plot because they're working with hundreds and hundreds of numbers. And a stem and leaf plot is a great way for them to condense it, so it's a lot easier for them to look at the data, and it's a lot easier for them to then see patterns, to find modes, and to just see a lot of other things. So the stem and leaf plots that we do today, you might think that they're kind of silly, and they kind of are for the small sets of data that we're looking at, but it would be really silly for me to give you, 100 points, 100 values, I should say, and to have you put them into a stem and leaf plot like a real statistician would do. So we're going to be taking a look at some smaller ones just that way you guys can get the hang of what a stem and leaf plot is. And so like I said, a stem and leaf plot is a way to condense them into a stem and a leaf. The leaf then is the smallest place value in the number. We're going to think about it as it's going to be the last digit in the number. The stem then is all the other digits that are not part of, whoops, and I have a typo here, that are not part of the leaf. So anything that's not part of the leaf is going to be our stem. And that's the first thing we're going to be taking a look at is what would be considered to be our leaf, what's our stem, and then we put things into the stem and leaf plot from there. So what I like to do when I'm looking at trying to make a stem and leaf plot is I always want to try to find my biggest and my smallest number because that'll help me to create those, find the leaf, and then to make the stems from there. So as I'm looking at this for adult dog weight, I see that my smallest number is 4, and it looks like my biggest number is 26. Okay, so now let's go ahead and we're going to make our stem and leaf plot. The stem always comes first, and then we have our leaf. Now, if you look at the last digit of every single one of these numbers, what place value is that? Hopefully you guys would say that the last digit for all of these numbers is in the ones place. So all of these numbers, the last digit is in the ones. So the ones place is our last digit, and that's our leaf. Let's look at our stems then. So the stem is everything else that's not in the last digit. And if I look, what's my stem then on my 4? If the 4 is the leaf, what's in front of it? There isn't a number. So our first stem is going to be a 0. Our biggest number, the leaf is a 6. So the stem, that first number then, is 2. So my stems have to go from 0, 1 to 2 because we include all the digits in between those. That's why it's helpful if you find your smallest and your biggest number because that'll help you decide where the stems fall between which numbers. Now let's go through our list. Let's start at the number 10. 10 has a stem of 1 and it has a leaf of 0. So here's my stem of 1 and I put the 0 in the leaf row. Now I'm going to look at 21. 21 has a stem of 2 and it has a leaf of 1. 15. This has a stem of 1 and the last digit is a 5, so that's my leaf. Now I'm going to leave some space here because our leaves, they need to go in order from smallest to biggest. So I might have some numbers in between 0 and 5 here, so that's why I'm leaving some space there. Now I'm going to look at 9. 9 doesn't have a number in the tens place, but if there's not a number there, then that stem is a 0. So we're going into the 0 stem and putting a 9 there. Again, leaving some space because there might be numbers smaller than 9. 17. 17 starts with a 1, so that puts us in this column. This row, and then we put the 7 in with the leaf. 6 again, this one does not have a number in the tens place, so that means it has a stem of 0 and the leaf goes in that row. 4, we talked about this one previously, that one has a stem of 0, and so the leaf is 4. 18 has a stem of 1, so the 8 goes here. 9 has a stem of 0. Now we already have a 9 there, but we rewrite it because we want to make sure you have every point in there. Now let's take a look at 26. Has a stem of 2 and a leaf of 6. 20, stem of 2, leaf of 0. 24 has a stem of 2 and a leaf of 4. So I need to squeeze that one in there. 11 has a stem of 1 and a leaf of 1. 13 has a stem of 1, a leaf of 3. 8 doesn't have a stem, so we said if it doesn't have a stem, it is a 0, so it goes in this row. And then 25, and I can see that I didn't leave enough space. So I erased that 6, that way I could squeeze in my 5 there. So here's our stem and leaf plot, but there's one important thing that's missing, is we also need to include a key. And on our last example that we take a look at today, you'll really understand the reason why we need a key. We need to tell the reader that, okay, if I'm looking at, let's say, the number 0, 4, what does that mean? Is that the number 4? Is that 0.4? Is that 0.004? What does that mean? So we need to put a key in. And what I do for my key is I usually just pick the first number in the table. And I'm going to tell the reader that for 10, the stem was 1 and the leaf was 0. So I do 1, big slash 0, and I'm going to tell that reader that's actually equal to the number 10 and not something else. Now the cool thing is you can pick any number in this table that you want to make your key. Doesn't matter. Some of my other classes that I've taught this in, they're like, my favorite number is 15, so I'm going to use that one. Some people said my favorite number is 24. Cool. Use that number if you want, but it does not matter. Pick any number you want to make your key. And I did miss one thing on here. Anytime you're making a display of the data, and a stem and leaf plot is considered to be a display, it's kind of like a graph that you would probably do in your science classes. We always want to make sure that we're labeling our graph. And so we can get that title from our table. So I'm going to label, title, the graph to be adult dog weight in pounds. So that way, again, the reader knows, what does a stem and leaf plot really mean? And I didn't leave a ton of room there. So I'm just going to draw an arrow. So that way that's on top of my graph. And again, I'm going to label it adult dog weight in pounds. And that pounds is important because maybe you have a really, really small dog, so maybe you're measuring in ounces, or maybe you are in Europe or something and you're measuring it using the metric system or something. So that pounds piece is actually really important as well. All right, now we're going to take a look at another one. This time we're taking a look at exercising time in minutes. And so I don't forget, like I almost did in the last one, let's go ahead and label our graph right away. So this is exercising time in minutes. Whoops. And we know we're going to have something called a stem, and we're going to have something called a leaf. Okay, let's take a look at our biggest and our smallest number, because that's, again, helpful for us as we're making our stem and leaf plot. So as I look at this one, looks like my smallest number is 10. And my biggest number, 65. All right. Now, let's take a look at trying to identify what is going to be my stem and what's going to be my leaf. So as I look at the entire table here, what place value is the last digit in every single one of my numbers going to be? Hopefully you guys are saying it's the ones place. So my leaf is going to be every number that's in the ones place. So let's look to our tens place and our smallest and our biggest number, because those numbers are not in my leaf. My smallest stem is a 1, my biggest is a 6. So that means my stems are going to go from 1 all the way up to 6, and I need to include all of them. And now let's go through our table, and we're going to put in each number in the appropriate stem and list its leaf. So 42 has a stem of 4 and a leaf of 2. 15 has a stem of 1 and a leaf of 5. 65, stem of 6, leaf of 5. 30. And now I'm going to go ahead and pause here. I'm going to give you guys some time for you guys to see if you can complete the rest of it. And when you're ready, go ahead and press play and then see if your stem and leaf plot matches with what I have. All right, go ahead and take a moment to see if your stem and leaf plot matches with what you have. Now, hopefully you're noticing that 5 didn't have anything in the leaf column, so we still have to keep that stem of 5 there. But notice that I just put kind of a squiggly line through that to show that there wasn't a leaf there at all. You don't have to do it. It's just something I do because it's visually nice to look at, to know that there was nothing there. But again, if you need to take a moment to take a look to see if your stem and leaf plot matches and have a discussion to see if you can figure out if you disagree, see if you can figure out why you disagree. And when you're ready, let's take a look at finding our key. So again, all of your stem and leaf plots need to have a key. And again, I always pick the first number in the table. So I'm going to be looking at 42. We said that the stem for 42 is 4, the leaf is 2. And 4-2 represents the number 42. So here's our stem and leaf plot for exercising time. Okay, let's take a look at an example for the number of hits for Reggie Jackson. As always, let's go ahead and make sure that we title our graph. And you can abbreviate number with the pound sign, as you guys know now is hashtag. Okay, so there's my title. Let's label our stem, and let's label our leaf. So this time, instead of having it in a table form, now we just have a list of the numbers. So again, I like to go through and to identify what's my biggest and what's my smallest number. And looking at this one, it looks like 158 happens to be my biggest, and it looks like 101 is my smallest. Now, this one's different because now we're looking at a 3-digit number. The first couple examples we've looked at are two-digit numbers where we went to the ones place and then the tens place. Now we have ones, tens, and hundreds. So we still want to think about what's my place value of my smallest, or the last digit of the number. If I look, the last digit of every number is the ones place. So all of these things that I'm just going to put a dot underneath of them, all of those are going to be my leaf. Everything else that does not have a dot underneath of it is going to be my stem. So instead of my stem just being a one-digit number, now I'm going to be looking at a 2-digit number. So if I take a look at the number 101, the 1 is my leaf. The 10 then is my stem. So my smallest stem is 10. Now let's take a look at 158. Again, the 8 is my leaf. That leaves 15 to be my stem. So I need to make my stem so it goes from 10 up until 15. And again, I'm going to do a few of these with you guys, and then I'll leave you guys to finish them and to see if you can make a key as well. So let's start with 138. So my stem is 13. The leaf, being that last digit, is 8. 151 has a stem of 15 and a leaf of 1. See if you guys can finish it off and make a key from here. Okay, So here's what your final stem and leaf plot should look like. Again, you'll notice that I did these squiggly lines in 11 and 12 because there weren't any numbers there. You don't have to do those, your choice. And also just want to point out, it's not a big deal if you have a space, like a big gap between your numbers like I do here in stem of 15. It happens that way just when you're going through and putting them in, so you don't have to feel like you need to rewrite them at all. And again, make sure you have a key. I decided to use 138. I was saying that the stem is 13, the leaf was 8, and that is equal to the number 138. Now let's take a look at one more example where we're creating one where we're using decimals. And this is where the key is really, really important. Again, to make sure that we're telling the reader, hey, we're going to be working with decimals and we're not working with the number 37 or something. So the process is still the same. The key is just the really, really important part. So that way we tell the reader what we're doing or what numbers we're working with. So again, let's put our title in. And we're talking about grade point averages for graduating seniors. And you guys may have heard of grade point average, is often referred to as GPA. So if you want to abbreviate that, that's fine. And for graduating seniors, and again, if you want to abbreviate grad, that's fine. In the real world, you should spell it all out, but it's fine. We can do a few shortcuts. Our stem, and then making our leaf. So just like we did for all our other ones, we're going to kind of pretend that there's not any decimals there. We're just going to be kind of looking to see what's our biggest number, what's our smallest, and then identifying what would be our stem and what would be our leaf for each one. So let's see here. Looks like my smallest number is 10.9 and my biggest number is 4.0. So let's take a look. In my number 4.0, my last digit is going to be my stem. It's going to be my leaf, leaving the 4 in this case to be my stem. If I take a look at 1.9, this last digit, which happens to be in the tenths place, is going to be my leaf, leaving the 1, which is in the ones place, to be my stem. So the last digit of every single number here is in the tenths place, and that's going to be my leaf, leaving all my numbers in front of the decimal point, really the ones place, that's going to be my stem. So my stem goes from 1 to 4. And I want you guys to see if you can finish just the stem and leaf plot, and then we'll take a look at writing the key together. So go ahead and finish the stem and leaf plot, and then we'll take a look at the key. So here's what your stem and leaf plot would look like, and then our key. Our key, again, I'm going to use the very first number, and I'm going to tell the reader that, hey, 3.7, we said that 3 was our stem, putting in the big slash here, and the leaf for that number was a 7. But we need to tell that reader it's not the number 37, it's the number 3.7. And that's the big thing for this one, is making sure that the reader knows what do those numbers really mean when you put the stem and the leaf together. So now let's take a look at some examples where I already give you a stem and leaf plot, and you guys are going to find the median and the mode, and then the difference between the biggest and the smallest numbers. So let's refresh ourselves from what we talked about earlier this week. What is the median? Hopefully you guys are remembering that the median is the number that's in the middle when the numbers are ordered from smallest to biggest. The mode is the number that happens the most often. So let's try to find the mode first, because that'll probably be our easiest, and then we can go through and try to find our median from there. So for our mode, what we want to look for in our leaf is we want to look for any numbers that are repeated. So I see these 4s are repeated. I see the 9s are repeated. I see the 7s are repeated. And I have these 0s. Which group of these happens the most? Hopefully you're saying the number 4 happens the most. So our mode has something to do with a 4, but it's not just the number 4 because I have to put the stem back on with it. So the mode is 24. And I would say that's the biggest mistake that students will make, is that they will say, oh, the mode is 4. because they forget to put the stem back on. So make sure you're using the stem to get the real mode then. Now let's go ahead and find our median. And our median, again, is our middle number when they're ordered from smallest to biggest. Now the good thing is that we don't have to rewrite these numbers if we don't want to. You definitely can. But what we can do is we can cross off in the chart here to find our median. Our smallest number is always going to be the first leaf that we see. So I can cross off this 8 because that's my smallest leaf. Then my biggest leaf is going to be the very last number. So whenever we're thinking about the smallest number, it's going to be the first number in the list. The biggest number is going to be the biggest or the last number in the list. So let's cross off our next smallest. So I'm in a new row, so it's going to be the first number that I see. Now I'm looking for the last and crossing off. Now as I move back here, I need to cross off the biggest number that I see, so that's going to be at the end of the next row. So now again, I need to cross off the smallest number, so I go to the next row, and I start at the beginning. Now I'm crossing off the next biggest, so again, I have to go to the end of the row, and I find that my middle number is 8. But again, it's not just the number 8, because I need to attach the stem back to it, so it's really the number 38. So my median is 38. Now let's find what's the difference between my least and the greatest numbers. We kind of did that as we were talking about that on here, that my smallest number is 18, my biggest number is 51, and difference means that we're subtracting them. So we end up with 33. And we're actually going to define this tomorrow. I should say actually on Monday, but this is actually us finding the range. We're finding the range of the spread of the numbers from the least to the greatest. All right, let's take a look at another example. Again, I like to find the mode first because I kind of mark things up a lot when I find the median. So let's find the mode. Again, I'm looking for any numbers that repeat more than once, and I'm going to underline them. So I have some 7s that repeat, 1s that repeat, and 2s that repeat. Do any of these groups of numbers repeat more than once? Or more than any other, I should say? Hopefully you're saying no. They each repeat 2 times. So that means all of those are my mode. But again, it's not just 7, 1, and 2. We have to put the stems back onto it. So the 7 really means 17. The 1 really means 21. And the 2 really means 32. So again, just like we had earlier in the week, we can have multiple modes. So whichever one happens the most, and all of these happen 2 times. Now let's find our median, again, our smallest number. Crossing off our smallest and our biggest. I finished this row and now I'm crossing off my biggest number, so I go to the end of it. I need to find my next smallest, so I go to the beginning of the row. And we end up with that 5 in the middle. Again, it's not just 5 because you have to put the stem back on it. So our median is 25. Now let's find the difference between our biggest and our smallest. Our smallest is 11. Our greatest is 33. So we find the difference between the two, and we end up with a range of 22. Again, we haven't officially defined that, but that's what the range is. It's the difference between the smallest and the biggest number. Let's look at another one. Now, in the first examples we've looked at, we haven't really been paying attention to the key because I knew with those that the key was set up where the numbers meant exactly what we assumed they would. But now if we take a look at this one, This one says the key 9-2 really means 9.2. So when we're putting that stem back on, we have to be careful to remember that these are decimals and not a 10 and a 1. So let's first find our mode. So I'm looking for any numbers that repeat more than any others. And I see that the 1 repeats. And I think that's the only one. So here's our mode. And again, it's not 81, it is 8.1. Now let's find our median again, crossing off the smallest and then the biggest. This one we have to be careful because there's a lot more stems than we've had in the past. And we have 2 numbers in the middle. Do you guys remember from earlier in the week, what do we do if there's 2 numbers in the middle for our median? And hopefully you guys are remembering that you add the 2 together and divide by 2. So I want to put the stems back on. So I have 7.4 and 7.6. Add those together and divide by 2. And you end up with 7.5 as your median. And that's when some of you guys might have been able to do in your head for that one. But working through it mathematically, that's what we would come up with. So be careful because you can have multiple medians. But again, you want to find the one that's truly in the middle to get your true median. Now let's find our range. Smallest number is 5.8. And our biggest is 9.2. Again, remembering that this key tells us that those numbers in the stem and the leaf are really a decimal. So if we subtract them, we end up with 3.4 for our range. One more example for you guys, like this isn't a total extreme as far as trying to find like working with lots and lots of numbers, but I did want to give you guys an example as far as working with a stem that has 2 digits and not just 1. But I want you guys to go ahead and see if you guys can find the mode and the median and then answer question B. And then when you guys are all done, see if you guys end up with the same answer as I do. So here's what you should end up for answers. Your median, hopefully you ended up with 129. You'll notice that I did all the crossing off of the numbers, ended up with this 9 in the middle. Again, here's my biggest numbers that I crossed off. And again, putting that stem back on. So the 12 and the 9 to give me 129. My mode, there were lots of numbers that were repeated, but again, you're looking for the one that happens the most, and the 8 is the only one that occurs 5 times, all in one setting here. So I put that 13 and the 8 together to get 138. And then the difference between the biggest and the smallest, my smallest is 110, biggest is 142. Subtracting them, you end up with 32. And then here's your homework assignment due for Monday. A lot of these, you're either making a stem and leaf plot or just like we did for the last couple of examples, you're trying to find the median, the mode. I would definitely rewrite those stem and leaf plots because that'll be helpful for you guys as you're trying to find that median then.